And a very good morning to you, Year 9. Thank you very much for coming to yet another remote learning session with Miss Pitt. Hello. Now, today's lesson is reviewing what we learnt last lesson about chromatography. So today, for this 50-minute lesson, we are securing our knowledge of chromatography. So if you haven't done so already, please go and complete the retrieval quiz. So pause the lesson video, complete the retrieval quiz by adding your answers into the table on your student worksheet, come back to see if you got them correct. Okay, so let's see what the answers should have been. So the technique used to separate a soluble mixture of dyes, chromatography. Be careful of the spelling because many students spell it chromatography, but it's actually an A, chromatography. Is pencil soluble or insoluble? Pencil is insoluble, and that is why we use it to draw the baseline in chromatography. The solvent used in chromatography, well, last lesson, the solvent that we used as an example was water. There are other solvents that can be used, for example, ethanol. 4 should have been the chromatography paper. 5, RF value. 6, the solvent front is the place where the water finishes moving. What can be said about a substance that travels the furthest up the chromatography paper? Well, if it travels the furthest up, it must be the most soluble. Paint is a formulation. Remember, a formulation is a mixture where the components have been carefully measured and mixed in specific quantities to make a useful product, such as paint. 9, if a substance is pure, it only gives one spot on a chromatogram. So from your results of chromatography, if a substance is pure, it will only have one spot on the results. And the challenge question, describe the positive test for oxygen gas. It will relight a glowing splint. So make sure you've either said blow the splint out or use a glowing splint. So the title today, Chromatography Review Lesson. And we are going to secure our understanding of how chromatography is used to find out if a substance is pure. Keywords, the same as they were from last lesson. So we've got pure, a substance made of only one kind of element or compound. A mixture, where you've got more than one element and or compound, not chemically bonded. Insoluble, meaning it does not dissolve. And chromatography was the technique we looked at to separate soluble mixtures. So, chromatography, a technique used to separate soluble mixtures, and it can find out if a substance is pure or impure. So you can see on the screen, we've got the result of a chromatography experiment, and we call this result a chromatogram. And this has tested 4 different samples, A, B, C, and D, and you can see that one of them was pure. Which one? Now, some of you might have thought it was C. However, the pure one would be A because we've got one result. What can we say about C? Nothing's happened to it. It hasn't moved. What can we say about it? It is insoluble. Good. It might have been a permanent pen. We could change the solvent to, for example, ethanol, and that might be able to dissolve it. We can see that B had 3 different components in, and D had 2 components in, and we can see that B and D both had the blue dye in it, both had the same component. And remember, not only can we compare our results, but we can also work out the RF value, the retention factor. Now that to work that out, it's all the RF value is the ratio between the distance moved by the ink divided by the distance moved by the solvent. And we measure that using a ruler. We can measure it in centimeters. If we want to be more accurate, we can do millimeters, but it is usually measured in centimeters. So if we were looking at the green spot, okay, I'd measure the distance moved by the ink, so the green, 2 centimeters, divided by the distance moved by the solvent, so I do 2 divided by 10.5, and that would give me my RF value for this green component here. Okay, so if possible, if you've got any of this laying about the home, I would like you to go and collect it. So a strip of paper, so any paper would do. I want you to cut it roughly to 4 centimeters in width and 8 centimeters in height. It's only roughly, so you don't need to measure it out. But I want you to basically cut it to the shape of a piece of chromatography paper. I want you to collect a pencil, a black felt tip. If you don't have a black felt tip, any other felt tip will do, or any other pen. I want you to get a ruler and then a glass as well, a drinking glass. And then what I'm going to do is I'm going to read the method of chromatography. I want you to carry out each step as I read it. So you might also want to get some water in the glass, a small amount of water as your solvent. And the glass, guys, is going to act as your beaker. If you've got a beaker, get one of them. Brilliant. Right. So chromatography is a required practical for GCSE. You need to be able to describe it yourself. So what I'd like you to do is, with the equipment you've just collected, I want you to follow this method. And I want you to actually do it. So, number 1, using a pencil, draw a baseline on the chromatography paper approximately 1 centimetre from the bottom. So on that strip of paper you've cut, what I'd like you to do is get your ruler and draw a baseline in pencil roughly 1 centimetre from the bottom. Number 2, add small dots of each sample or ink that you are testing onto the baseline. Make sure the dots are not too close together. Now, if you've got more than one felt tip, you can use more than one. You can test 2 different ones. If you've only got the one felt tip, that's fine. So all you need to do is on that pencil line on the baseline is add 1 small dot of the ink. Number 3, add a shallow amount of water to your glass. Okay, so this would normally be a beaker in school, but because you're doing it from home, it's probably going to be a glass. Now, what I'd suggest you do is hold the chromatography paper next to the glass so you can see where the bottom of the chromatography paper is going to reach and fill the water up to that point. Number 4, hang the chromatography paper in the beaker, ensuring that the water line is below the sample spot. So that's a really important point, guys. If you don't make sure that the water is below the sample spot, if it's above it, the ink will dissolve into the water. Okay, and the experiment won't work. Now, normally in school we'd use a splint. We'd fold the top of the chromatography paper over the splint so we can hang it into the glass. Okay, so what I would suggest you do for this is you use your pencil. So fold the top part of your chromatography paper over the pencil so that you can hang it into the glass and the pencil can sit across the top of the glass. So once you've got your chromatography paper sitting on top, hanging into the glass, and the bottom of it's just touching the water, what you need to do is wait for the solvent to reach the top of the chromatography paper and then take it out. Now, this happens faster with actual chromatography paper. If you're using just normal paper from home to do this, it does take a little while longer. Now, keep an eye on it. Once the solvent reaches the top, you need to take it out and allow your chromatogram to dry. And once it's dried, you can then use a pencil to mark the solvent front, the point at which the solvent reached. Okay, so last lesson, just leave your experiment going. Like I said, the solvent will take a little while to reach the top of the paper. So focus back on the lesson, keep an eye on that as we're going through. So the instructional, so this is an instructional phase, obviously, because of the banner. And I just want to go through the questions that you had last lesson for your consolidation. Some of you were answered them very well. Some of you got a little bit confused as to what the question wanted from you. Now, they are, once you sort of understand them, pretty straightforward. Now, this was probably the strongest out of the three. So, a student used paper chromatography to investigate the colours in different inks. The diagram shows the apparatus the student used. So, you can see that they've got the beaker, they've got the chromatography paper in the beaker. They've got a lid on top of the beaker. That's absolutely fine. It just stops the solvent evaporating. It says it's got a hanger to hang it into the beaker. Um, it says the start line is drawn in ink. So the student made two mistakes in setting up the apparatus. Identify the two mistakes and describe the problem. So the start line is drawn in ink. So that's one mark because that's a problem. Sorry, that's the mistake. What's the problem with that? Well, if the start line is drawn in ink, the start line would take part in the experiment and ruin the results. We don't want the start line taking part in the experiment because that's not what we're testing. Okay, so they should have drawn it in pencil. So one mark, the start line is drawn in ink. The second mark comes from describing the problem. The start line will dissolve and take part in the experiment, which will ruin the results. Now, the second problem, if you study the image, you can see that the solvent line is way above the ink spots. So the solvent line is above the sample spots. This means that the ink will wash into the solvent back down into the trough, and the experiment won't work. Number two, the student then set up the apparatus without making any mistakes. The chromatogram obtained is shown below. So you can see they've labelled the solvent front being up the top here, the start line at the bottom, and they've got the different colour inks. Which of the ink is the most soluble and why? Well, the most soluble one is the one that's travelled the furthest up the paper. So you can see that for 2 marks, you need to say the yellow is the most soluble. What that would get you 1 mark, and your second mark comes from saying because it's travelled the furthest. And number 3, calculate the RF value for the red ink. It's giving you the data in the table, and it's giving you the equation below. So it says that the distance moved by the red ink was 13 millimeters. The distance moved by the solvent was 44. So the RF value is the distance moved from the start line divided by the distance moved from the solvent. So the ink divided by the solvent, 13 divided by 44, and you needed to record your answer to 2 significant figures. And that was 3 marks. So task number 1, I want you to pause the lesson video and complete this task. So you've got a chromatogram of different colour inks and the dyes they contain. So you've got purple, green, yellow and brown, and it shows you what dyes those inks contain. So you need to answer these questions, come back to the lesson video for your answers. Okay, so the answers are: name the inks that are pure substances. Now remember guys, pure means they only contain one component, so it should have been green and yellow. Brown's got 3 dots, so it's got the most number of dyes. Purple ink contains red and blue dye. The most soluble was yellow because it's the highest up the paper. The least soluble was blue because it's lowest down on the paper. The baseline is drawn in pencil. Why is the baseline drawn in pencil? Because pencil is insoluble, so it won't dissolve and take part in the experiment. We don't want that. The task 2, last lesson, I noticed most of you were weak on calculating RF values. So here is a question on RF values. It says a student carried out chromatography investigation to separate the different dyes in coloured inks. The diagram below shows her results. So she's got the black ink that she separated, and she's got red, blue and yellow, and they're her standard reference material. So what you need to do is work out the distance moved by the solute. Remember, solute is the solid being dissolved, so that would be our sample, that would be our dye. The distance moved by the solvent, so that's the solvent front, the point at which the solvent reached. And then you need to work out your RF value. Now remember guys, you will need to measure the distances in centimetres, and you will also need to remember the RF equation. So the distance moved by the solute, the dye, the ink, divided by the distance moved by the solvent. And there's your ruler for your reference point. So go to your student worksheet, complete this task, and then come back. Okay, so I haven't provided you with the answers for this because I know that some of you will be seeing the ruler at certain points. So, for example, with the yellow dot, some of you might have said it was 3.5. Some of you might have said it was 3.8. So I will mark your RF value calculations when you submit your work. Now, task 3. What I would like you to do is write a clear method for how to carry out chromatography on 3 different pens. So pause the video, go and complete your method and come back. Go and do it. Okay, thank you. Again, each one of you would have written your method slightly different. However, if we go back to the method slide, you should have said baseline in pencil is your first point. Add in the dots, add in your sample along the baseline. Add in a small amount of water to the beaker, hang in the chromatography paper in the beaker, and you do get a mark for saying ensuring the water line is below the sample spots. Waiting for the solvent to reach the top of the chromatography paper, taking it out and then allowing it to dry. So that leads us on to the consolidation task. So what I would like you to do is complete the Seneca task set by following the link provided. Now, if you have forgotten your password, you need to click the link, forgot password, and set a new one. Now, that will send you a message to your Google Mail, your Gmail, and it will give you a link to follow to reset your password for Seneca. Thank you for taking the time to complete the lesson. I hope you understand chromatography, and I hope you got a really good chromatogram on your paper. Thank you very much, guys.